The focus of today's lesson is how to solve an absolute value equation. So your learning target is I can analyze an absolute value function and solve absolute value equations. Absolute value is defined as the distance of a value from 0. If you're thinking about a number line, this could be distance in a positive or negative direction, but the distance will always be a positive value. So just like -5 is 5 units away from 0, so the absolute value of -5 is 5. And we use these straight up and down bars to represent absolute value. So whatever would be inside those bars is what we're finding the absolute value of. The graph of absolute value creates a V shape, and there are 3 possible options for solutions for an absolute value function. This first graph does not cross the x-axis, and we know that wherever we cross the x-axis is our solutions for that function. So since this does not cross the x-axis, no solution. So that's one possibility when looking at absolute value. Another option is that we only touch the x-axis, but we do not cross through it. So that would be one solution. And then the option that we're going to see the most is where we cross through the x-axis, so 2 solutions. All right. So solving absolute value equations by hand is almost the same exact thing as solving regular equations, with one major difference. In most cases, you have 2 solutions. So my example earlier, talking about -5, the absolute value being 5, now we're looking at it backwards. We want to see what value of x, the absolute value of that value, gives you 5. So we know that when x equals 5, the absolute value of 5 will also equal 5. Because the distance from 0 is 5. It's also true that -5 in the absolute value bars will give you an answer of 5. So for this equation, there are 2 solutions, -5 and +5. They both work. Isolating absolute value equations is similar to isolating an equation for x. So what I want us to do is think back to previous math courses and how we solve for x. So in this example, we do not have any absolute value bars. The first thing I would do to isolate x is to subtract 9 from both sides. So 5x equals 135. And then I would divide by 5. And if we go to Desmos to type in this value, 135 divided by 5 is going to be 27. So our final answer is x equals 27. Now when we're solving absolute value, same idea, we want to isolate, but this time it's not x that we're isolating to start out with, it's the absolute value bars. So I'm going to subtract 9 first from both sides. Everything else on that left-hand side stays the same. Now to get the bars by themselves, I need to divide by 5, both sides. The opposite operation of multiplication. Left with 3x minus 6 in bars equals 27. Now this is not solved for x, but from this point we can now solve the absolute value equation in steps that I will show you in just a minute. There are some more examples here. I'm going to skip down to 3a. You can try 2a and 2b on your own. So for 3a, the first step to solve for x would be to add 11 to both sides. So we're going to get 2/3 x equals +8. Now, to get rid of the 2/3, we can multiply both sides by the reciprocal, which is just the flipped fraction of 2/3. So 3/2. Okay, so that's going to become 6 divided by 6, which is an understood 1. So all that's going to go away. we're left with 1x equals 8 times 2/3, which I'll type into Desmos. 8 times 3 over 2 is going to give us 12. So x equals 12 is our final answer for that linear equation. Now looking at the absolute value equation, same steps. We would add 11 first, trying to get those absolute value bars by themselves. All right, and then multiply by 3 halves on both sides. All right, so we have solved for the absolute value bars. That's as far as we're going to go for right now. And then on the next page of the notes, we will continue with how to solve an absolute value equation completely. So on page 2 of the notes, you have another example of solving a linear and then solving a absolute value equation with similar characteristics. But we're going to skip that one. Feel free to try it on your own. We're going to skip down to how to solve absolute value equations, since that's our goal for this lesson. So we're going to isolate the absolute value portion of the equation first, which is what we've been doing on the previous page. There's a note here that's very important. Never distribute into the absolute value bars. So you may have been tempted back on this previous page to multiply 2/3 inside the 2x and -10. Do not do that, okay? We're going to isolate the absolute value just exactly how we got rid of this 2/3 by multiplying by the reciprocal, okay? So never distribute that into the bars. Once we have isolated the absolute value equation, the portion of the absolute value, we are going to split the equation into 2 pieces, one positive and one negative, which I'll show you in just a second. And then finally, when we're finished solving for x in both equations, we're going to check our solutions by substituting our answers into the original problem. So what I give you to start out with. So our first example is 2x plus 6 in absolute value bars minus 3 equals 13. First step, of course, is to get the absolute value bars by itself. So we're going to add 3 to both sides. So 2x plus 6 in absolute value bars equals 16. Now, next step is to split the equation into 2. So I'm going to draw 2 arrows to separate my work. I'm going to have one as 2x plus 6. Here I drop the bars, okay, so this is going to become a linear equation. And then I'm going to make one equal to 16. And then the other equation I'm going to make equal to the negative of this, so -16. I'm going to solve each of these for x and then plug back into my original equation to check the answers. So subtract 6. 2x equals 10, divide by 2. X equals 5 for that first equation. Second equation, same steps, except for -16's on the right-hand side. So subtract 6, we get -22, divide by 2, we get -11. So now let's check those 2 answers, and I'm going to use Desmos. So the way that we're going to check those answers is plug into that left-hand side and see if we equal 13, the original equation. So absolute value of 2 times 5 plus 6 and then minus 3 gives us 13. And if we replace that 5 with -11, we also get 13. So that those 2 answers are both correct, and we can circle those as final solutions. Example 2 of solving absolute value equations. The first thing we're going to do is subtract 13 from both sides. Or subtract 23, sorry. So 4 and then 5x minus 10 equals -20. Now remember, we do not distribute into absolute value equation, or into absolute value bars. So we're going to divide by 4. We get 5x minus 10 in the bars equals -5. I'm going to stop right here. Typically we would make our 2 equations and continue. But what's happening here is we have absolute value equal to a negative number. And if we go back to our definition of what absolute value is, it's the distance of a value from 0. It's always positive. So if you isolate the absolute value bars and it's equaling a negative value, then you're going to have no solution. Now don't worry, if you were to make your two equations and solve, you would get two answers to those linear equations, but then if you went and plugged back into the original, the solutions would not make the equation work. So at that point, you would also know no solution. All right, and then two more examples. I'll actually just do this one with you and then leave this one for you to try. So this example, absolute value is already by itself, but notice that we're not equal to just a number. We have an algebraic expression on the right-hand side as well. So the way that we're going to set this up is we're going to take x plus 5 out of the absolute value bars, and that's going to be the left side of both equations. Now for the right side of the equation, we're going to leave 3x minus 7 for the first equation. Typically we would make this negative. So if this had just been a 3, we would make it negative 3. But since we have more than one thing, everything changes signs. So this is going to be a negative 3x and then a plus 7. Alright, so I'm going to solve both of these for x. So here I'm going to move the 1x, or subtract 1x from both sides, so that I'm left with a positive number of x's. So 5 equals 2x minus 7. I'm going to add 7 to both sides. And I get 12 equals 2x, divide by 2, x equals 6. I'm not going to circle that yet because I need to check my answer. And then the second equation, I'm going to add 3x to both sides to keep my x's positive. So 4x plus 5 equals 7. Subtract the 5 from both sides. So 4x equals 2. Divide by 4. We get 2/4, which is equivalent to 1 over 2, 1/2. So I'm going to type that in. Keep in mind that we're going to get a numerical value for each side because both sides have x. So we need to plug in the x to both sides. And then for this equation to work, those two values need to be the same. So looking at Desmos, we're going to type in, starting with 6, so 6 plus 5. And we get 11. And then if we type in 3 times 6 minus 7, we also get 11. So we know that this first solution works. I'm going to go ahead and circle that. But now I'm going to go back and just change where I plugged in 6 to a 1/2. So 1/2 plus 5 is 5.5. 3 times 1/2 minus 7 is negative 5.5. Since those are not exactly the same, one's positive, one's negative, then we have a solution that will not work here. So we just have one solution in this case. Okay? So same idea with this one. You would just make two equations, change everything about this side in that second equation, change both signs.